The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
Yes, it is Janine Young joining us with some interesting stories from the pages of New Scientist, plus a competition which we're going to tell you about in a second as well. Hello to you, Janine.
Good morning, Wammo.
First up today, we're talking about P-Power. Scientists may have found the answer to the world's energy crisis through urine.
That's right, you said it correctly. It sounds really dodgy and it sounds a bit, but it's actually not. The huge amount of urine that's produced every year is extraordinary. The 7 billion people on our planet are producing about 10 billion litres of water that we produce ourselves, urine, every day. 10 billion litres. And so you've got to take a look at that and think, well, can we do anything with it? It has something called urea inside it, and some people produce more than others. Depends on how much water you've had to drink and the like. Depends on what you're eating, so and so. But this can actually be split to produce hydrogen. Now, hydrogen is a fuel, as people would know that, and it's finding ways to be able to take the urea out of the urine and do something useful with it. You don't want to just flush that away because it's actually quite a useful resource. So researchers are looking at the different types of fuel cells that might be able to use this. Some, as I said, are talking about splitting hydrogen out from it. And this is chemistry, pure, basic, simple chemistry, trying to work out ways to be able to split this out. There are other fuel cells that are a basic cathode and anode, and they're putting just straight urine. They're not trying to concentrate it out. They're not trying to produce hydrogen. They're just taking straight urine in reasonably concentrated form. And they're producing simple things like nitrogen and carbon dioxide and water, but more importantly, the electrons that are released from this particular reaction, and I'm not going to bore everybody at 9:10 in the morning with that kind of chemistry, but the fact that you get electrons off this means that you can actually siphon those off in to another carrying circuit and produce energy. Now, at the moment, it's only producing about half that of a AA battery. It's not that much, but if you think about maybe an office block that has 200 to 300 people in it, if that's all being siphoned into energy production, that could actually make it commercially viable.
Yeah, but the challenge would be to collect all this and collect it without everything else that you might collect at the same time.
Yes, and there are processes in place to take care of number twos. The amount of energy that's required to take care of waste is extraordinary. It's estimated about 1.5% of all of the electricity produced in the United States is used to deal with waste. So they do have processes in place to be able to take care of that kind of thing. If you actually use a different type of fuel cell that's based on little bugs, bacteria, they love to eat things. And if you put them in an oxygen-free environment, again, you can siphon off these electrons. There's a pilot plant being put through its paces at the moment, somewhere in the US, and they're taking murky water that has a range of different things in it. So it's not just number ones and number twos. It's also, brackish water. It could have all sorts of other contaminants in it. And this pilot plant is showing that you can actually take care of contaminants. It's not just the urine that it will run on, because it'll break down organic matter. Then they're actually getting energy out of it. And so it could be that we have an almost limitless resource, and if you include animals, there's even more, and it could potentially be a net gain of energy instead of a drain on the system. It's a nice idea to explore.
It is. Okay, well, from that to water of another kind, some research into the origin of tropical storms.
And this is, as you've said before, we've talked about this, this is really, really important. It's really also very relevant stuff, because hurricanes and typhoons cause massive amounts of damage each year, and there's interest in climate change as to whether or not these are going to increase, decrease, whether their intensity is going to increase even though there's fewer of them. It's actually really kind of important. Researchers have been looking at whether or not phytoplankton have a role to play in generating hurricanes. Now, the water of the ocean looks blue, of course, but it can turn into a kind of murky, deep blue when there's a lot of phytoplankton around. So they've been looking at whether or not the cloudiness of the ocean has anything to do with the formation of hurricanes, and it turns out that it does. They're looking at gyres, G-Y-R-E-S, for anyone who really wants to go and check them out. They're parts of the ocean where you get currents forming in such a way that they help generate weather, effectively. It's where hurricanes form. They found that if you have a clear area of ocean in these gyres, you actually get fewer hurricanes developing than if they're murky. This has to do with heat. If you have a clear area of the ocean, then it means that the heat can actually penetrate further down, up to say 100 metres. It tends to be murkier at the edges. So if you take this heat a long way down, you have currents that will be able to take this heat away. However, if you have murky centres, then it's not able to be dissipated away quite as easily. You don't have these deep ocean currents doing what they're there to do. And that's what helps form hurricanes and typhoons. So they're estimating that if you have fewer phytoplankton, which they're saying under climate change scenarios may in fact happen, you could in fact have a 70% reduction of hurricanes forming across the Pacific. And of course that has implications for which small tiny island nations get hit by them on the way through.
Yeah, and as you say, very timely at the moment with the major flooding in Pakistan, and of course warmer air means more water in the air as well.
Exactly.
All right, finally, let's talk about this fantastic competition that is only happening in Australia and New Zealand.
Yes, we're a bit special. I'm a little bit excited about this one because Mythbusters, I think most people would know about this program. You take an idea and you test it. Guess what? It's actually a science program at its heart.
Yeah.
The whole idea is to take an idea and test it. Love it. But urban myths and other ideas that you get, like does a goldfish really have a 3-second memory? These guys have tested these sorts of ideas. Does swearing when you are in pain actually make it easier to bear? The answer, by the way, is yes.
Huh.
Find that quite interesting.
Yeah.
Anyway, we've teamed up with Mythbusters to give Australian and New Zealand residents the chance to come up with a myth and have it tested on the next series of the program. So, whole idea is that you want to go to mythbusters.newscientist.com, enter your myth, make it original, make it interesting, make it exciting. More importantly, make it a myth that's never been tested before. Because if it's been done before, well, they're not going to test it. So make it an interesting, exciting one, and you go in the running to have your name mentioned on the program and to have your myth tested by the boys themselves.
Golly, that's really exciting. You really have to put your thinking cap on for this one. Have you thought of anything? Well, you wouldn't want to give it away, though, of course.
Well, I'm also not allowed to enter.
Okay.
I work for New Scientists, so I can't. So all I'm doing is telling people about it and getting them the chance to do it because, if it's someone I like and know, that'd be even better. So, get your thinking caps on, people, and get those myths out there. Very,
very nice. All the details up, of course, newscientist.com, and the stories we've just been talking about in the New Scientist magazine next week. Thanks so much, Janine.
See you next week.
Got a track now from Super Tour.